All right. So we started a little late, so we'll finish little late. Okay. So we might go till 8:15. So quickly, so we have covered or studied till unit 6, which was on vectors, and we are starting a fresh unit from today, that is called matrix, or plural of that will be matrices. Now, a very unrelated question to you both. So who has watched the movie Matrix? Anybody? Nobody? Too old a movie for you guys? Okay. So it has no direct correlation with the Matrix movie, but then you would have, I'm not a big movie buff, okay, so I don't know much about the movies, but based on whatever I have heard about the movies, it has story where you, too much of gadgets, too much of technology, too much of graphics is there, and you will see everything being all scattered, or too much of what do you call, lot of flying objects, lot of scattered objects you will see in this movie. Maybe I'm wrong with my judgment, but yeah. Anyways, let's not try struggling too much with what the story of the movie was. But matrix is something that relates to dealing with numbers in groups. Now, we have dealt with all different types of numbers. We talked about natural numbers, whole numbers, integers, fractions, rational numbers, irrational numbers, whatnot. And then we also talked about imaginary numbers or complex numbers. Now we have come to a point where we are not happy with just dealing with one number at a time. When we are dealing with a group of numbers or array of numbers, that is what is given a name called matrix. Did you guys come across this concept before, or you are hearing for the first time? And based on what you guys say, I will accordingly change the tone of how I'm going to teach it. Any prior experience with matrix? Fish.
I remember going over them to a certain extent, but I've never actually learned them in school.
Wonderful. That makes me relevant. How about you, Dev?
I haven't heard of them before, sir.
Wonderful. So see, I'm still relevant. That's a good news. Okay. So yesterday we had a sizable hail, and because of that I had to move everything in the classroom, and I had to arrange things a little bit. Okay, so now let's look at a situation where we are talking about when you look at these numbers in isolation, these are just different numbers. Depending on what number we are dealing with, be it whole numbers, be it decimals, whatever. But these are individual numbers and they have names to it depending on the property or the behavior they depict. When you look at them as a group, let's say each one of us as individual, we have identity, we have name, we have all the properties that relates to us. And then when we expand the horizon a little bit more and look at all of us being part of a family, meaning this is a number family, this is Dev's family, this is Prisha's family, this is my family, right? So my family has me, my wife, my kids. Dev's family has Dev's parents, Dev and his siblings. I'm just assuming, okay? Same thing, Prisha, parents, Prisha and her siblings, if any. And I'm not doing that. So net, when you look at things in groups, when you logically put them together, that array of information, these are like individual information. It's a number 5, it's a number 10, it's minus 10, 60, minus 20. These are individual numbers. When you put them together, look at them as a group or array of information, that is called matrix. Yeah. So this is one matrix, this is another matrix, this is another matrix. Now, if I want to represent this, I can always say, I'll say, okay, I have a matrix A, and good thing is all the matrices are always written as capital bold letters. Okay, so I'll say matrix A with equals, let's say 5, 10, 15, 8. Let's say this will be called matrix A, which has an array of elements or 4 elements into it. Likewise, I can have another matrix which, let's say, has 15, 2, let's say 2.6, 11, 17, let's say, 1/4. So what do you see between these two matrices? I am saying that these are matrix A and matrix B. So if you want to relate to it or make an interpretation out of it, what is that observation that you are having here? Dev, Prisha, please don't be shy. Tell me what is your observation. It's okay. Your observation will help you derive a conclusion actually. No observation? Are you guys able to hear me okay? Yeah, Dev.
Wait, sir, could observation be that B has a fraction and a decimal in it?
Okay,
While A
that,
doesn't.
okay, that's one observation. Anything else? Prisha, if I start speaking, then you will say, yeah, that's something that I also observed. So that's why I'm wanting you guys to observe first, okay? So anything that you see with your bare eyes, without stressing too much about it, it's not math. It's simple. Opening eyes, as long as your eyes are with you, you can see them. What is that you will observe here?
The first one has 4 numbers, the second one has 6.
That is another observation. Yep. What else?
There's 15 in both of them.
Has 15 in both of them, okay? That you have gone a little too deep, okay? Okay, so see, here is the thing. When you look at this array, as you guys said, this has 4 elements, this has 6 elements. And again, as you observe, some have common numbers, some have, and one of them have only natural numbers, one have decimals and fractions as well, right? Now, this third observation. Now, if you look at it a little more granularly, you will see that there are 2 rows of data here. And again, there are 2 columns as well. So you can look at this as 2 rows and every row having 2 columns of data. Whereas if you look at this guy, here also you have 2 rows, but you have 3 columns of data. Does that make sense? So every array that you see or you will see will have the data represented in the form of rows and columns. Now, if I give you guys another array, let's say C, which is represented like this: 1, 2, 4, 7, 3, 9, 8, 6, 15, 18, 1.7, 2.9. Now what do you see? You are seeing 3 rows of data and 4 columns. So that is the first identity of an array. When you're looking at array, it is nothing but, when you're looking at matrices, the first thing is that it's an array of information, array of data, and then these arrays are in the form of rows and columns. So this is a matrix which has 2 rows and 2 columns. This is a matrix which has 3 rows and 4 columns. So rows and columns, that's how, like the way you see an Excel sheet. That Excel sheet is nothing but a form of a matrix. Somebody would have visualized matrix, and that is how they created Excel sheet, where you have rows and columns of information. So we got the first practical example of where matrices are used. That is Excel sheet that you guys deal with every now and then. I'm assuming everybody has dealt with Excel sheet, right? Okay, be it Excel sheet, be it Google sheet, whatever. So this is the first practical example of this one. So every matrix that you talk about has rows and columns of information. So tomorrow if you see 2 numbers, one number A being 3 or other matrix, let me call this also a matrix. So whenever you call a matrix, you'll put that as inside the big bracket as the form of an array. If I have a second matrix which says 2, 9, 1.5, 4, 3.2. So this is also a matrix which is array of information which has only 1 row and 1 column. That's sad. It can be a regular number also. But this is another matrix where you see 1 row and 1, 2, 3, 4, 5 columns. Is that part understood so far? How do you look at a matrix? How do you imagine how a matrix would look like? Correct? We have just seen the introduction of it, and we were thankfully able to relate it with one of the most practical, relatable example, that is Excel sheet. Now let's look at what are the other things that we want to learn today. So we talked about what is the basic introduction of matrix, and then we talked about rows and columns. So rows and columns, if you want to call that in a mathematical term, these are called dimensions. So now if you look at this matrix, it is 1 by 1, 1 row, 1 column. It is a matrix which is 1 by 1. If you look at this matrix, this is 1 row and 5 columns. So this is 1 by 5. You don't represent it this way, not like coordinate. You say this is a matrix which is 1 by 1, meaning 1 row and 1 column. First one is your row, second one is your column. This one is 1 row, 5 columns. So this is a matrix B which has a dimension 1 by 4. So basically the number of rows and number of columns, this is how you represent them, and these are called dimensions. So we learned what is a matrix, what do you mean, what do we mean by matrix, how do you represent a matrix, and what do you mean by dimension of a matrix. So you'll not say, okay, this matrix has 5 rows and 20 columns. You'll say it's a 5 by 20 matrix, or the dimension of the matrix are 5 and 20. Does that make sense? Okay. Now let's see. Let's pick up a matrix. Yeah. So let's pick up a matrix which is, let's say, matrix B. 2, 4, 3, 6, 9, 11, 8, 3, 7.2, 5, 19, 2. If I have a matrix like this, what will be your first reading? How will you make me understand how do you read this matrix? What will be your call out by just looking at this matrix? Pretty sure, Dave. Is it not 3 by 4 matrix? Agree? Don't agree? It's a 3 by 4 matrix, right? You have 3 rows and 4 columns. Now, in this one, these are called the elements of the matrix. This one, 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 and this one. So basically you have total 12 elements in this matrix. So just by looking at the dimension 3 times 4, this gives you the number of elements you have in this matrix, right? So every number that you see here, every data that you see here, those are called elements of the matrix. Now, if you have to, I talk about this element versus this element. Any idea how would you represent these elements? I mean, how would you say that whether you're talking about this element or you're talking about this element? Any thought? And I know you guys know about it. I mean, at least something relatable. So, any thoughts about this? If I say, how do you represent or talk about this matrix, this element of the matrix versus this element of the matrix? Any nomenclature or any identification method that you can think of? No? You guys need to be more or less shy. Give it a shot. Is this not an element in the first row, second column? Is this not an element in the third row, second column? If I am talking about 19, is this not an element in the third row, third column? Yeah? Pretty sure? Confusing you? Not confusing you? Okay, so yeah. So basically if you look at this one, this is first row, first column. This element is first row, third column. This element is second row, third column. So this is how you represent it. If you have to talk about 4, this element, you will say this is element 1, 2. If you have to talk about this one, this number 2. So there is a difference between this number and this number in terms of position in the matrix. This one is, let's say if I say element, this is 1, 1. And if I am talking about this element, I am talking about this is third row and fourth column, 3, 4. So this becomes your way to identify these records. So, I mean, I'm sure you guys would have started programming also in some of your, as one of your subjects. I'm just assuming, right? Because in high school, some of you who have interest in programming, you end up going this way, right? So this becomes a very important concept that you will use very often, where you have to deal with a number of data, number of information, and you have to pick which data you want to deal with or which data you want to do operation with. So this becomes your way to locate a data. Okay. In terms of programming, this is how you locate it. Even when you go further deep into the infrastructure side of computing, where how the data gets stored in database or other things like that, this becomes your way to locate the coordinate and the position where the data is actually stored on the hard disk. Okay. So basically, in summary, what I'm trying to say is, if you have a matrix is nothing but an array of data, and it is always represented as rows and columns, which we call as dimension. So if we are looking at this matrix, you're talking about a 3 by 4 matrix. So 3 rows and 4 columns. Likewise, if you have to deal with a much bigger data, data element, if you have, let's say, 50 rows and 200 columns, this becomes 50 by 200 matrix. This becomes the dimension, which depicts that this is your number of rows of records and this many columns. So basically every row, there are 50 rows and every row has this many data elements. Is it making sense so far, or? Okay. So now, if somebody says that you have a matrix, multiply that with a scalar. So let me not put a very complicated matrix here. Let's say if I have a matrix A, which is, let's say, 2 by 3, 2, 4, 8, 4, 9, 2, or let's say 7. Let them be unique numbers. So I have a matrix, it's a 2 by 3 matrix. Okay? Meaning 2 rows and 3 columns. If somebody says, if this is A, what will be the value of 5A? Can you guys tell me what could be a possible answer for that? Just a logical guess. I'm saying I have a matrix, 2 by 3 matrix, where the elements are 2, 4, 8, 3, 9, 7. So what will be the value of 5A? What will you do? What you can think of? And there's no penalty for a wrong answer. So let your out of the box thinking go in whichever direction you want to go. And again, you guys will probably think that we should have thought about it. So this is A. When you're talking about 5A, essentially what that means is you're multiplying each and every thing of A. And A doesn't have its own identity alone. When you say A, you're talking about all these data elements. So when you're multiplying 5 by A, you're essentially talking about multiplying each and every element of A with 5. So this is what it will become. Okay. So basically this is what is called multiplying a matrix by a scalar. So if you have a matrix and this is a scalar number, this doesn't have direction, right? We learned about vectors and scalar in the previous few classes. So this is a scalar quantity. It doesn't have direction, just has magnitude. So when you talk about multiplying a scalar with a matrix, essentially you are talking about multiplying each and every element of the matrix with the scalar quantity. Sometimes when we don't relate it, or there could be, if you have to just think out of the box, you might think that okay, A has 6 elements, so if I'm multiplying by 5, I might have 6 into 5, 30 elements. And then you'll start grappling with yourself that okay, what would become the dimension of this one? That is not the way we have to go. You always look at, if I'm talking about a matrix, I'm essentially talking about matrix as a group of elements. When I'm multiplying something with the matrix, I'm essentially talking about multiplying the same thing with each and every element of the matrix. That's what is happening here. Is it somewhat digestible? Now, so in the simplest form, tomorrow if somebody says, I have a matrix B equal to 5, 2.9, 6.4, what will be the value of 3B? There should not be any doubt in your mind. It's simple as I have a matrix 1 by 3 matrix, 1 row 3 columns, which I have a 1 by 3 matrix where somebody is talking about multiplying that with 3. So matrix has no meaning to it. Matrix is only known by its elements. So if I'm been asked to multiply that with a scalar, essentially I've been told to multiply each and every element of the matrix by the same scalar quantity. That is what it's all about. Matrix, multiplying matrix with a scalar. Now, if I say I have a matrix A, let's say it's a two-dimensional matrix, 5, 3, 5, same number, 4, 7. I have a two-dimensional matrix A and I have another matrix B, which is 1, minus 2, 4, 3.5. If somebody says A plus B, what will come to your mind? What would you do? I mean, addition, subtraction, multiplication, division we have learned. So I'm saying that now, instead of adding numbers, we are trying to add two matrices. Matrix A and matrix B. What would come to your mind as an instant reaction or approach for solving it? Prisha, Dev, I want to hear you guys. And any reaction is fine. There is no answer as a wrong answer. Like there is no wrong question. As long as you are not in the examination hall. Let me correct myself. Yep. What would come to your mind as an instant thought process? Are you guys getting bored or you're still thinking? No response? Okay. So, okay, let me not pester you guys. I'm just kind of trying to make you guys think, because what will happen is sometimes, we learn things in the class and then when you're in the examination hall, sometimes you will not recollect the formula, you will not recollect everything that you know about it. Sometimes under the stress, we end up forgetting things, and that is when what is the thought that you put around for solving a problem becomes your savior. So that's why I was kind of trying to make you guys think about it. Now, when you have a matrix A and matrix B, this is a two-dimensional matrix. I mean, two-dimensional as in 2 rows and 2 columns. Every matrix is mostly two-dimensional only. There is no one-dimensional matrix. It's a two-dimensional matrix. Number of rows, number of columns. So, row is one dimension, column is another dimension. So, this is matrix. It's a 2 by 2 matrix, and this is also a 2 by 2 matrix. When somebody says add the two matrix, as long as you see the dimensions are the same, meaning this is 2 by 2, this is 2 by 2, then you can think of adding or subtracting them. So if you have been asked to add A plus B, what you will do is first row, first element, first row, first element. I mean first row, first column, first row, first column of both the matrix you will add. Then first row, second column, first row, second column, you will add them. And now 3 plus minus 2, you know that becomes 1, so that's fine. That thing doesn't change. Second row, first column, second row, first column, second row, second column, second row, second column. That is how you will add, meaning the element, you will match the elements in both the matrix and add them. So let's say this one's element is 1 comma 1 plus this one's element, let's say this is A's element, this is B's element, B is 1 comma 1, you will add. B is 1 comma 1, you will add. That will become your first element of the resulting matrix. Similarly, A is 1 comma 2 and B is 1 comma 2. You will add and that will become the second element. So let me say A plus B becomes C, a third matrix, and what is the value of that? A is 1 comma 1 and B is 1 comma 1. So 5 plus 1, it became 6. Now A is 1 comma 2, B is 1 comma 2. So 3 plus minus 2, that becomes 1. Now this one's second row, first column, 4 plus 4, 8. This one's second row, second column, this one's second row, second column, 7 plus 3.5, 10.5. This became your third matrix. By adding these two matrices, this became your third matrix, which is nothing but you're adding the elements and the same position on both the matrices, as long as the dimensions are same. Is this part understood so far? Dave? Okay. So look at this. Let's go to the next level. When somebody says, and again, these are conceptual things. Trust me, you're not learning anything very complicated. If I have matrix A and other matrix B, let's say both have same dimensions. Okay. Let's say this one is 2 comma 2, 2 by 2, and this is also 2 by 2. Okay. A and B both are 2 by 2, or 3 by 2, whatever. 3 by 2 and 3 by 2. Both have same dimension. Number of rows are matching, number of columns are matching. Then you have been asked to add two matrices. C will be A plus B. Okay, let's say C is a resulting matrix which is coming by A plus B, and you know that, okay, you will put both the matrices and add the 3 comma 2. So 3 rows and 2 columns. So you will add the numbers in the matching position. And then your C will become, which will be sum of this, 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 sum of this. You will have this thing. Now I am saying, if I have to do C as a resulting matrix by adding two matrices, be it A plus B or be it B plus A, both will be the same. If I have to add these two matrices, whether I am doing B plus A or A plus B, both will be the same. Do you guys agree? Okay. Now, so let's try deriving some conclusion out of it. So if I have two matrices with matching dimensions, matrix A with, let's say, 3 comma 2 this dimension, and other matrix with same 3 comma 2 dimensions, and I have to add them, then A plus B will be equal to B plus A. So it doesn't matter which way I am adding, whether I am adding B's elements with A's elements or A's elements with B's element, it doesn't matter. But if you have to subtract, then this will not hold true. Any thoughts why? And give me as simple an answer as you can think of. Again, I am repeating my question. I have two matrices with matching dimensions. Okay, I am saying A plus B will be equal to B plus A, meaning whether I am adding A's element to B's element or B's element to A's element, my resulting matrix will be the same. However, if I do A minus B versus I do B minus A, there is a difference. So A minus B will not always match with B minus A. There could be some exception scenarios when it can match, but it will not match otherwise. I mean, conceptually this is not right. Can you guys tell me why I am saying so, or why I am making you guys believe so? Any thoughts? I'll give you guys a great news. But before that, you have to answer this question. No guesses? Dave Prisha, I want you guys to at least acknowledge and tell me whether you are getting a thought around this, or you're not getting a thought around this, or this is just way too stupid to even answer. No? No response? No reaction? Are you guys able to listen to me carefully, or you are not able to? Because when I don't get a response after 2-3 reminders, that gets me worried that is my network working fine? Are you guys able to hear me okay? Okay. So now this was a very easy one, okay? Let's say if I have matrix, both are 1 by 3 matrix, okay? I'm just picking an easy example so that it doesn't take too much time for me to write it on the board. If I have A as 1, 5, 2 and B as 5, 6, 9. If I'm talking about A plus B, what I'm saying is I'm adding the matching position numbers, right? And that becomes my matrix C, which will be this plus this, this plus this, this plus this. So I'll have 3, 1, 1 plus 5 is 6, 5 plus 6 is 11, and 2 plus 9 is 11. So this becomes my resulting matrix. Now when I'm talking about subtracting, I'm essentially talking about the same thing. First element minus first element of this, second element minus second element of this, third element minus third element of this. So if I'm talking about A minus B, I'm taking this as a base and subtracting the corresponding elements from the second matrix. So now if you look at this, if this was my A, 1, 5, 2, and 5, 6, 9, if this is A and this was B, so A minus B, let's take first example, C is my resulting matrix by A minus B. What is the value? 1, A minus B, so 1 minus 5, minus 4, 5 minus 6, minus 1, 2 minus 9, minus 7. So A minus B gave me this matrix. Now let's say B minus A, let's say that gives me a D, resulting matrix is D. So B minus A, this time we will do reverse calculation. So 5 minus 1, that is 4, 6 minus 5 is 1, 9 minus 2 is 7. Aren't these different? Yeah. So what it means is, simple conclusion from this would be that if I have two matrices with matching dimensions, if I'm adding them, A plus B, B plus A, both are same. Doesn't make a difference. It's like 1 plus 5 or 5 plus 1, both are same. But when I'm subtracting one matrix from the other one, A minus B is not going to be equal to B minus A. As simple as 1 minus 5 is not equal to 5 minus 1. Yeah. So that is what is a relatable fact. Okay. I know you guys might be thinking, okay, matrix is a new concept. We have not come across this, but I'm kind of at times thinking that am I teaching even a loaded concept to you guys? Is it something which is worthy of being taught to you guys? And I feel these are much easier concepts because there is nothing complicated about it. It's just another way of looking at things. So far we have been dealing with numbers in isolation, with individual values. Now we're talking about, let's look at, instead of looking at individual numbers, let's look at group of numbers. And when you have group of numbers, you have to have some way to organize that. That is where the dimension comes into the picture. Where you say, okay, fine, I'll represent them in rows and columns. Like in the Excel sheet, we can keep hundreds or thousands of records. So likewise, it will be row and column. Those are called dimensions. Now, when I look at those numbers, a group of numbers, when I'm dealing with adding two metrics or subtracting one matrix from another, this is what will be my interpretation. And remember this, you will never subtract, when you are, let's say, subtracting or adding, you will not deal with this number and this number. It has to always match the position of the element in both the matrix. Does that make sense? Okay. Now let me trick you guys a little bit. And though I'm saying that I'm tricking you guys, but if you just pay a little bit of attention, you will make me fail. Meaning, I will not be able to trick you guys. 4, 6, 9, 2, 8, 3. This is one matrix. I have another matrix which is 2, 4, 3, 6. If I say do A plus B and tell me what will be the resulting matrix, what will be your approach for doing it? Or what will come to your mind immediately? Give it a minute, think about it and let me know.
I would see if they have like similar dimensions, and if they do, then I would add like the matching components.
Okay. How about you, Dave? What will be your reaction to it?
I think I would do the same thing as Krish.
Same thing. Yeah. So you both are, at least I'm feeling a little more confident now. Two reasons. One, you both responded. So this is still an engaging class. And second reason, which was even a better reason for being happy, was that you are thinking the right direction. If you ever have, so this is like, they don't have matching dimensions. Even if I was probably the smartest person on the earth, I would not be able to solve. Because if I add one apple with one oranges, I will never have two oranges or two apples. Neither 1.5 apple or 1.5 oranges either. It's like this is apple, this is oranges. They are identifiable only and only if they are having matching dimensions. Otherwise, it's like dealing with two aliens from two different solar system. Okay, they have no connection with each other if they don't have matching dimension. As simple as that. And that is what is called. If you are given this kind of situation to deal with, you will say that this is an undefined situation where both don't have matching dimensions. So there is no manipulation that we can do with them. Be it adding or be it subtracting. You will just surrender, say, okay, fine, go to somebody else who can solve it. For me, this is undefined. Is that okay? So this is with respect to what we wanted to understand. What is a matrix? What are the different elements of a matrix? What do we mean by dimension of a matrix? So elements are nothing but these are elements, okay? And how do you recognize them? By their position, mapping it to row and column. And then the dimension we heard. Then we also learned about what do we mean by multiplying a matrix by a scalar. Meaning, when you have A, if you have to make it 2A, you will end up multiplying each and every element with 2. That is what is multiplying by scalars. And then we saw how do we do operations between matrices. How do we add two matrices? How do we subtract them? What are the key considerations that we have to take into account for doing addition and subtraction? And what will be the situation or the circumstance where we will give up and say, okay, go to somebody else to solve this if this is undefined. Yeah? So these are the key things that we wanted to cover today. And even if we started late, we were able to at least cover the topic that we wanted to cover in the class today. Now there are a couple of announcements that I wanted to make. Next week, next Wednesday, there will be no class. The reason being, I'll be out on a business trip for my work related stuff. So I'll be back. I'll be away from Monday evening till Thursday evening. So we'll probably skip one class in between. But once I'm back, we'll probably try doing little extended classes for next 2-3 weeks, so that we can still catch up on what we are missing by not being in the class next week. Okay, that is one announcement. I hope that is okay for you guys. And the second announcement, which is more like a proud moment for me. As you guys would know that I teach around 450-500 kids back in India, and these are the kids from underprivileged part of society. I mean, not as privileged as we are. And from that group of kids, 3 of my kids have secured state level rank from 1 to 10 in the board exam. So that's a very proud moment for me. I just wanted to share that with you guys, because it makes me very happy when I see my kids succeeding, and that will be the case when I see you guys also doing very good in your future exams. So out of excitement, out of moment of pride, I thought of sharing that with you. Okay. And these are the kids essentially from Bihar, from a very remote place called Rohtas, Dinara in Rohtas. I mean, I had never been to that place, but I have kids from that place, and they have done awesome. I mean, they have secured state level rank, which makes me very proud as a teacher. All right. So with that being said, I will still let you guys go. I know it was a much shorter class, but at least with respect to whatever we wanted to cover today, we have covered, and we'll keep working on what we are doing, so that in future I can talk about Dev, Prisha, and many of my students saying, okay, my students are making me proud. Okay. Any other? I'm sorry, Peter.
I just said thank you.
Yeah. No, I mean that's the goal I'm working towards. Okay. I mean that's the only takeaway I have for whatever I do. So, yep. All right. I'll let you guys go. Enjoy the rest of your evening. Have a good dinner. Have a good night's sleep, and we'll meet on Saturday, Sunday. We'll meet. No gap in that one. Just that next Wednesday we'll not have a class. Okay. All right.
Thank you, sir.
All right. Bye bye. Bye bye. Take care. Bye then.